Okay, just 2 minutes for everyone to join. All right, let's go. Let's talk about Bitcoin. Let's talk about ICP, and let's talk about what we can build on the internet computer with this integration. So I hope you see my screen. You should see Bob. Bob has a problem. Bob has Bitcoin. He has a lot of Bitcoin, but he's a bit disappointed because he cannot use his Bitcoin. Cannot use his Bitcoin because he wants to do DeFi. He wants to play with this new thing that he has heard about. It's called decentralized finance. And decentralized finance, he wants to try Uniswap. He wants to try Curve, the famous applications. Wants to play with his money, but he cannot because the problem with his Bitcoin is that the DeFi application that he wants to try are on a new network. This new network is called Ethereum. And the Bitcoin are on the Bitcoin network. And the problem is there is no way for the Bitcoin to be moved on the Ethereum network because by definition, they don't even exist on the Ethereum network. So it's like I'm rich on this network and I don't have anything on this network. So the way that we've solved that in blockchain and in cryptocurrency in general is to create what's called as a bridge. So the bridge in the middle is an entity, usually a set of entities that has two roles. They control the wallet. So let's say, sorry, on the right you have the wallet, which is on the Bitcoin network. So it's an address on the Bitcoin network, and this address is controlled by the bridge. And on the other side, the smart contract on Ethereum is controlled. One smart contract on Ethereum is controlled by this bridge. So essentially, you send your Bitcoin to the wallet, and then the entity will create a wrap Bitcoin on the Ethereum network, and you trust this entity or set of entities to essentially match one-to-one the ratio Bitcoin sent, Bitcoin created, wrap Bitcoin created. And then you've wrap Bitcoin, they actually exist on the Ethereum network, so you can play with it, and Bob can play with it. He can use them for stacking them in a liquidity pool. He can use them on Curve. He can play with them. He can do some trading on Uniswap, and so on. The problem with this approach is the bridge side of things. So there has been many hacks, and there's been many Bobs that lost their Bitcoins. And in the case where the bridge is hacked, or the team is malicious and decide just to rug the investors, you are left with wrap Bitcoin. But those wrap Bitcoin, they don't have any more value because, well, the bridge is broken. So essentially the only asset that really matter are the original Bitcoin, but you don't have access to them anymore. So we don't want that to happen to Bob on the internet computer. And the cool thing is that on the internet computer, Canisters can receive, hold, and send Bitcoins. So there is always a bridge. There will always be a concept of a bridge. You can call it however you want. There is always trust assumptions when you move between different networks. But the trust assumption in the case of the internet computer is the canister itself. So it's a much simpler security model and a much cleaner, I would say, setup that conceptually, if you're already using the internet computer, you're already kind of trusting that the consensus and the whole infrastructure is safe. And so it doesn't add an additional security assumption. And also, it's really clean for developer. It's really easy for developer to conceptualize that. Think of your Bitcoin as just a Bitcoin, think of your canister as just a Bitcoin wallet. So you actually have an address on the Bitcoin network and you are able to sign transactions. And so from the point of view of the Bitcoin network, there is not a specific like a canister type. Like it's just a normal wallet and you wouldn't be able to differentiate a canister based address from a traditional like user address on the Bitcoin network. So if you look at the Bitcoin blockchain, you don't see that. So everything is happening on the side of the internet computer. Now, how does this magic work? Actually, it's very simple to explain. There are two things that we need to solve. The first thing is how do we connect the two networks? So how do we make it possible for a canister to know its balance? So to know how much Bitcoin he owns on the Bitcoin network. And the second thing is how do we sign transactions? So let's start with the first point. How do we know how many Bitcoins our canister has and what is the balance? To solve that, we need to connect two Bitcoin nodes. So you can see on the right, you have the Bitcoin nodes. On the left, you have the ICP nodes. And we cannot avoid, we have to essentially run light nodes of Bitcoin on the internet computer. So the internet computer nodes, they run kind of a light nodes and they connect to the Bitcoin network like this. So if you look deep into it, they essentially randomly connect to 5 different nodes to make sure that the connection is as random and secure as possible. And essentially they are connected, like the two networks are intertwined and you have access to the Bitcoin blockchain. When you have access to the Bitcoin blockchain, you can track what's called as UTXOs. And so UTXOs, unspent transaction output, gives you access to the balance because you basically know what transactions have been confirmed. And so what is the current balance of my canister? So once the ICP nodes are synchronized, they essentially synchronized the UTXOs inside what's called as the Bitcoin canister. And so the Bitcoin canister just essentially tracks the Bitcoin blockchain on the ICP network because it's inside the canister. And actually, I can maybe show you some stat about this canister. So this is from the ICP dashboard. Here, this is a Bitcoin side. So you have the dashboard. And if you go here, it explains how this Bitcoin integration work. You have access to some statistic, and you also have access to like the Bitcoin canister memory usage, the current block height. So this should always be synchronized with the latest block height of the Bitcoin blockchain. There is, of course, always like a slight delay, but it's pretty up to date. And also it tracks so you can see here the tracked Bitcoin UTXO. So the number of Bitcoin unspent transaction outputs that are being tracked by the Bitcoin canister. This is very close to the number of UTXOs on the Bitcoin network. So it's not exactly the Bitcoin blockchain that is replicated, but it's the necessary part that we need just for transaction and knowing our balance. So once we have that knowledge, any canister, so your canister as a developer is able to call the Bitcoin canister in just one line of code. So it's going to be an inter-canister call, just like we've seen in the bootcamp. And you can access your balance just in a simple call like this. So of course, many things happening behind the scenes, but from a developer perspective, it's just get balance, await get balance, and you receive your balance. Now, the second part, how do we sign a transaction? So just quick reminder for everyone here, how do we create transactions and how do we sign transactions? Well, there is a public public key cryptography. So this is the basis. We have a private key, we have a public key. The public key corresponds to a Bitcoin address, and the private key is the one that we use to sign a transaction. And so that's how you can verify, combining the public key and the private key, how to create a transaction that is trustworthy. So the main problem that we face with this approach is, where do we store the private key? Because if we store the private key inside the canister, then anyone, like for example, the nodes that are hosting the canister, would be able to read this private key and would be able to access the funds. And we don't want that, because that wouldn't be secure. So what we do on ICP is the concept of threshold ECDSA. So essentially, there is not one key, but there are multiple shares of the key, and all the shares are distributed across the nodes. So if you have access to one share, you cannot sign a transaction. If you have access to two shares, you cannot sign a transaction. If you have access to 2/3 of the share, you can sign a transaction. So essentially, it's the same as having a consensus on the key itself. The private key is never stored in one place. So there is not like there are only shares that exist. There is not one single place or single human that can access the private key. Also, shares are regularly shuffled, so it adds some security to the set. And if you want to create a signature, you need to go through consensus. So you cannot avoid the consensus side of things. And the assumption of this consensus are the same as the ICP consensus. So in terms of security assumption, as I said before, you don't necessarily add something more. Now that we have those two ingredients, you can pretty easily understand how everything works. So we have this Bitcoin canister that is synced with the Bitcoin blockchain, and it acts as a kind of gateway slash proxy for every other canister on the internet computer. So you can check balance, create transaction, send transaction, and then those transactions will be broadcast on the Bitcoin network directly through the connection between the ICP nodes and the Bitcoin nodes. And once those transactions are on the Bitcoin network, then this is up to Bitcoin networks, Bitcoin nodes to do their job. So this is why it's called a native integration. There has been some discussion around, is it a bridge? Is it a different version of a bridge? I think it doesn't really matter. What matters is the security. Like, is it safe? More than how do we call it? And because there are always problems with terminologies, but if we really look at the security assumption, that's what matters in the end. And there are security assumptions with this approach. It's just much cleaner than a lot of potential, like previous setups that we've seen. So I'm not claiming that this is perfect. I think it's always like a trade-off. You always have like trade-off between the security, how much you want to store, and those topics, if you really want to dive into it, it's pretty intense, pretty deep, but this is a clean setup. So I think that's potential for evolving and making it more and more like safer. Well, now we have a problem actually. We have a problem because on DIC, everything is pretty damn fast. When you do a transaction, you are used to sending your ICP in 2-3 seconds, and you are used to instant feedback. But even with this approach, we cannot overcome the limitation of the Bitcoin network. So it means that if we were to, every single time that we have to work with Bitcoin, like process payments, we would use the Bitcoin network. We still have to go through consensus on the Bitcoin network. So we still have to pay the fees. We still have to wait for the Bitcoin network to reach consensus and to reach confirmation, which takes a lot of time depending on the activity, but like 15-20 minutes usually. So how do we overcome that? We have Chainkey Bitcoin, which is essentially the kind of steroid version of Bitcoin on ICP. And so this token is native to the internet computer. So This time you can think of it as the wrap Bitcoin that we had in the first slide, but on the IC. It's completely transparent the way it's operating. So the way that we mint, burn, and create the chain key Bitcoin token is completely transparent because it's actually done by a canister. So once you have the chain key Bitcoin in your pocket, you can have 2-second transactions because you are now on the IC, and you can also pretty easily integrate with any dApps. We've seen how to create a token on the chapter 3, and we've talked quickly about the ICRC1 standard. Chain key Bitcoin is an example of the ICRC1 standard token implementation. How does it work? It works with 2 canisters, the minter and the ledger. So those canisters are under the control of the NNS, so the DAO that governs the IC. So essentially they are under the control of no one. So they are, how to say it, like there is not one entity that controls it, even if the NNS is one entity. And so you send your Bitcoin to the minter, and the minter has an address on the Bitcoin network. Then the minter confirms the transaction, send a mint request to the ledger. So the ledger is the one that tracks the chain key Bitcoin balances and also work with the transaction. And then you can use it on OpenChat, on all other platforms, and so on. So I can actually show you later. We have a quick demo of a proof of concept where you can pay with chain key Bitcoin. And so if you are interested to build applications around like Bitcoin processing, like Shopify kind of type of things, or like simple payment system for markets and store, like even physical store, I believe chain key Bitcoin is a pretty interesting use case. So actually there are a few places in the world that have been tried. I've been trying with chain key Bitcoin to implement payment system. And essentially that's how it works. It's still like there's still security assumption, but honestly, I feel more confident having something that is controlled by a code that I can see. It's fairly simple to understand how it works. It's just a bridge, but the bridge is not like a few companies, but it's a canister. So it's a trade-off. Like it's how it works. I think it's a clean approach. I really like how simple it is for developers, and that's chain key Bitcoin in a few slides. In terms of use case, this is what we have right now, but there are more use cases. So SocialFi is a big one. I use OpenChat quite a few times to send money around. And so OpenChat has integration with chain key Bitcoin, but also other ICRC1 token. You can also use it for on-chain decentralized exchange on the IC. So there is a Helix market that released pretty like a few weeks ago. Chain key Bitcoin, well, we've explained. Crowdfunding, so you can use chain key Bitcoin on a funded platform to essentially fund projects using chain key Bitcoin. Bionic is an ordinal marketplace, so it a little bit different. It uses the threshold DCDSA signature scheme that we've talked about to create what's called as reserved ordinals. So it makes the experience of essentially playing with ordinals much cheaper and much more accessible, but it also makes it connected with the Bitcoin side of things. So if you want to basically move your ordinal on the Bitcoin like side of things, you can do it pretty easily with Bionic. And finally, one that is also exciting is Finterest. It's a non-custodial lending protocol that essentially enables you to get interest on your Bitcoin. So most of the Bitcoin are stored somewhere doing not anything productive, just resting. And so with this bridge, with this crypto lending platform, you can essentially use your Bitcoin, make them accessible to potential borrowers, and receive interest without having to give custody of your Bitcoin to an entity. So it would be under the custody of a canister. And let me show you a quick example of like what all of this can be used for. So the example that I've chosen is IC proof of store. And it's pretty cool. So let me show you how it works. It's a simple setup to create a store and having your store able to receive Chain-key Bitcoin. So let's sign in. Everything is local here. So I have a local version of internet. So I can log in with this one. I can see my Chain-key balance here. So I have 0.9. You could charge for like a service using directly your QR code. What I'm going to do is I'll open up a new store. So another tab, I have a second store. Here I have 0.1 Chain-key Bitcoin. And if I open the send here, so I am able to basically, let's do a transaction between our store here and the second store that is here. So I need the principal that is here. I'll store 0.1. And here I should receive a notification whenever this is processed. And payment received, 0.1 Chain-key Bitcoin. So with this, I believe we are pretty close to really using crypto for payments. Like now, the fees problem are solved. I think there is a huge market and opportunities for actually like builders, to create kind of packages or like service for commerce that would like to use that. Even like physical store, I don't see a lot of store that actually accept crypto. That's something I'm annoyed, like, because it's been what? It's been like 13 years since Bitcoin has been created, and we still cannot really pay anything except maybe online. But offline in the physical world, I don't see many shop like accepting crypto payments. And I think it's mainly a problem of accessibility. Like if with this proof of store, you could create like a little box, kind of plug and play, where you just go to a shop and tell them, okay, like this is $100 for the box or $200, and you just put your QR code here, install this application, 2-second setup, and you just receive, and it creates invoices. Everything is like legal, and the accounting is taken care of. I really believe this would be, not saying easy, but this is doable on the IC, something like this. And once you have like one proof of concept, you can easily market it and get your first customers and so on. So maybe that would be a project to work on for some of you. If you want to take a look at the code of this one, it's a really good example. I really recommend to take a look. Let me send you the link. It's a community, like it was created by Christopher. It's a community example that is well structured. It uses a lot of like necessary tools. So I think what's interesting there is the integration with Chain-key Bitcoin. So the ICRC1 standard. Second, you have an example of a React frontend. This is a React frontend. And third, you have an example of how to integrate locally with internet identity. So you've seen that whenever I oops. I need to log out. So yeah, whenever I want to log in, I use internet identity. So it's really easy to to do it. And also, yeah, it's a little bit complex to set up internet identity locally. I had quite some issues in the past. So if you want to look at this repository, everything is explained there. And yeah, it's a really solid example. Now let's take a look at the chat. It's this part an UX problem, but also a volatility problem. Yeah, I mean, I think for like huge company, I think yeah, they wouldn't necessarily play with Bitcoin volatility. Might like smaller shop owner and smaller business owner might be more open, to understand that yeah, this like the volatility is a problem, but it's also an opportunity, like because it can also increase and it can decrease, but it can also increase. I feel like the conversion to USD would be not so hard to do actually, like having automatically the whatever money, like you could have multiple currencies sent and it would always convert it to like USDT or USDC. And my feeling is really the UX problem has been huge. Like there hasn't been so like if you think about it, even on the accounting side of things, like taking like recording all transaction, the having a very easy login system for the person to like have maybe like a dashboard to manage or something. I just feel like there is not enough value or like not enough solution there in the market. And it's not just about Bitcoin and crypto being volatile. But yeah, you're also right that there is a volatility problem as well. I find it interesting how IC clearly doesn't want to use the term wrapped and always say Chainky Bitcoin is a digital twin. I found it confusing at first. Yeah, so this is like a good point. I think it's just because they want to showcase how different the technology is, which is true. But I agree that it has been confusing for people, just because uh, just I froze. Just because people are used to some terms and now you have new terms on the IC, so they feel like, oh, okay, they are trying to like hide some technical realities behind technical terms and jargon. I think we should stick to the basic, but well, I would say it's a bridge, but it's not really a bridge. Like I think we just need to explain how it works simply like this, and it will make its way. Like once you understand how it works, and you dive into the security assumption, it's not hard to understand. That this is what I like about it, is the clarity of it. Like it's clear and it just like feels native. Native, I think, is a good term, even if it's not like magical. Of course, there are always going to be like security assumption and issues. And yeah, so that was the Bitcoin integration. Today we'll talk about the HTTP side of things, so how to integrate with Web2, which is also pretty cool. And now we have the chapter 3, chapter 4. So I'll close this session and I'll see you there in a few minutes. Bye, everyone. Yes, just the last question. Yeah, they are also working on Ethereum. Actually, it's already out there. So if you look at the dashboard that I've shown earlier, where was this one? Here. There is a Ethereum side. And hopefully soon there will be Chainky Solana. Hopefully soon there will be Chainky USDC, USDT maybe. And hopefully Chainky Doge at some point. All of them will go there. All right, see everyone in a few minutes.